Okay, let's unpack this. Have you ever stopped to think about what truly powers the world's shift towards, electric cars or smarter
Or
homes?
even just more efficient renewable energy
Right.
sources.
Because we interact with these technologies daily, but there's this kind of hidden engine driving massive changes in how we use and convert energy.
Right.
So today we're taking a deep dive into the global power electronic device and module market. And our mission really is to extract the most important nuggets of knowledge, maybe some surprising facts, from a detailed market forecast,
hmm
helping you understand not just the scale, but the profound direction of this crucial global sector.
And what's fascinating here is that while we often focus on the end product,
Yeah.
the electric vehicle, the solar panel, the power electronic modules are, well, they're the essential unsung heroes behind high efficiency energy conversion.
Unsung heroes, I like that.
Yeah, basically, they're the silent conductors of electricity. They efficiently control and convert electrical power. Think of them as the brains that make your electric car accelerate smoothly or ensure your solar panels deliver stable power to the grid.
Or even just charging your phone, right? Minimizing waste?
Precisely, all while minimizing energy waste.
Yeah.
They truly lie at the heart of the world's transition toward electrification, digitalization, and sustainable energy. And this market isn't just growing, it's really exploding.
Exploding. How so?
Well, look at the numbers. It's moving from just over $36 billion globally back in 2021 to a projected $75 billion by 2033.
Wow, 75 billion.
Yeah, that's a compound annual growth rate of over 6%, which means the market is consistently expanding year after year at that rate. It
Yeah.
points to, truly sustained demand.
That's a huge leap in just over a decade. That really indicates a foundational shift, doesn't it? So, when we look at that kind of dramatic growth, what are the primary drivers behind it? And where are we seeing the most dynamic changes, like on the global map?
Well, the overarching drivers are the global push for decarbonization and electrification across nearly every sector. That, coupled with the rapid advancement of digital technologies.
Okay.
Power electronics are fundamental to all of it. Regionally, it's a story of both established giants expanding and new markets accelerating really rapidly.
Right.
Take North America, for instance. It's a significant player, projected to double its market size from over $10 billion in 2021 to more than $20 billion by 2033.
Doubling.
Yeah, and the United States dominates this,
Yeah.
driven largely by its aggressive EV adoption goals and ongoing investments in renewable energy infrastructure.
Hmm.
But what's often overlooked is the strong, steady growth in Canada and Mexico, too. It reflects a broader regional integration of these technologies.
Okay. So North America is doubling down on its existing strengths. How does that compare to the powerhouse region we often talk about for tech acceleration? Asia Pacific, are we seeing different growth patterns or drivers there?
Asia-Pacific is indeed the undisputed powerhouse, yeah. And its trajectory is even more dramatic. It surged from about $13.5 billion in 2021 to project over $30 billion by 2033.
30 billion. So bigger than North America's projection.
Oh, yeah.
Oh.
And with a robust CAGR of nearly 7%. Here, the drivers are incredibly diverse. China, as you'd expect, leads the charge. Massive manufacturing base, rapid deployment of EVs, smart industrial solutions.
Right, the usual suspects in scale.
Exactly. But what's truly fascinating, I think, is India. It's not just showing growth. It's experiencing the fastest acceleration in the entire Asia-Pacific region. It's leaping from $1.5 billion to nearly $3.9 billion by 2033. That's a CAGR close to 8%.
Whoa, 8% CAGR for India. That's really remarkable acceleration. What specific factors are fueling that? Is it policy shifts or new industries or big infrastructure projects? What's making it expand so much faster compared to others there?
It's really multifaceted in India. It's propelled by a combination of government initiatives like Make in India, which promotes domestic manufacturing,
Oh, okay.
massive infrastructure development, and a rapidly expanding renewable energy sector.
Mm,
Think solar farms and smart grids, all of which heavily rely on efficient power electronics.
makes sense.
Plus, you've got the burgeoning domestic electric vehicle market and a growing consumer electronics industry adding significant demand. It's a profound and rapid restructuring of its energy and industrial landscape.
So it's hitting on multiple fronts there.
Precisely. And elsewhere in the region, I mean, Japan and South Korea remain major contributors, of course,
Yeah.
and Southeast Asia and Taiwan are also rapidly building out their own digital and industrial capabilities.
That paints a clear picture of dynamism. Okay, shifting gears a bit. What about Europe? It has such a strong industrial heritage. How are they positioned in this market? Are their drivers maybe different, perhaps more focused on, say, existing industries and those stringent efficiency regulations they have?
Absolutely, that's a good point. Europe is forecast to nearly double its revenue, too,
Hmm.
from about $7.4 billion in 2021 to almost $14.5 billion by 2033.
Okay. Another doubling, roughly.
Yeah. Germany, being an industrial powerhouse, is a major hub. It's exhibiting the highest KGR in the region at 6.5%.
Germany leading Europe. Okay.
Its growth is fueled by ambitious targets, like
Mhm.
the Energiewende, that's their big transition towards renewables, which fundamentally relies on advanced power electronics for grid stability, energy conversion, smart manufacturing, all that.
Right. The whole system needs it.
Exactly. And while the UK and Spain also show strong growth, particularly in areas like EV charging infrastructure, we also see countries like France and Italy making solid progress in modernizing their industrial and energy sectors.
So it sounds like while some regions, like parts of Asia, are seeing maybe more explosive growth, others, like parts of Europe, are demonstrating really consistent strategic expansion. Is that fair?
I think that's a good way to put it, yes.
Okay. Are there any maybe emerging regions that are truly making their mark, perhaps driven by entirely different economic or developmental factors?
That's an excellent point,
Hmm.
because while the larger economies often grab the headlines, we are seeing impressive expansion in South America, the Middle East, and Africa.
Really? Okay, tell me about that.
While South America, for instance, is projected to grow from $2.3 billion to nearly $5 billion by 2033. Brazil leads here, naturally, but the standout is actually Argentina.
Argentina.
Yeah, with the highest growth rate at over 7% CAGR. This signifies a real push towards industrialization and sustainable energy solutions across the continent, particularly as they look to, you know, optimize their vast natural resources.
Interesting. Over 7% in Argentina. And what about the Middle East and Africa? These regions often seem quite different in their development paths. How do power electronics fit into their growth stories?
The Middle East is showing strong potential. Its market is increasing from about $1.48 billion to over $3.1 billion by 2033.
Okay.
Here, the growth is deeply intertwined with ambitious national visions. Things focused on economic diversification, smart cities, large-scale renewable energy projects.
Right, like Saudi Arabia, UAE.
Exactly. Countries like Saudi Arabia and the UAE are pouring investments into advanced infrastructure. The UAE is projected for over 7% CAGR. That highlights a profound shift towards digitization and electrification in those Gulf economies.
Another 7% plus region. Okay.
And Africa, often seen perhaps as a follower, is actually catching up pretty quickly, going from $1 billion to over $2.1 billion by 2033. South Africa and Nigeria are the major players there,
What are they focusing on?
investing in energy infrastructure, telecommunications, and a nascent but growing industrial base. This really underscores Africa's increasing commitment to modernizing its energy backbone and integrating advanced electronic systems. It's a pivotal step, really, for its role in future global energy networks.
It's clear this isn't just a regional thing, then. It's truly global,
Mm.
with really diverse drivers behind it all. But okay, beyond the geographical breakdown, what are the key applications that are truly fueling this growth? Is it mainly EVs, or are other sectors like, say, renewable energy or industrial automation just as significant?
That's where the rubber meets the road, as they say.
Yeah.
Electric vehicles are certainly a massive driver, no doubt. They demand increasingly efficient and compact power modules for everything from motor control to fast charging.
Right.
But industrial applications, think robotics, factory automation, high-efficiency motors, they're just as crucial.
Yeah.
Huge market there. And then there's renewable energy, which includes solar inverters, wind turbine converters, grid stabilization systems, all of which are absolutely reliant on advanced power electronics for seamless integration and, maximum energy harvest.
So EVs, industrial renewables, any others?
Yeah, even consumer electronics and home appliances are contributing. As smart devices demand more precise and efficient power management, it all adds up.
That makes perfect sense. These components really are becoming ubiquitous. Okay, looking forward then. Are there any emerging technologies? Like, I've heard about wide bandgap semiconductors. Are things like that poised to accelerate this market even further? What innovations should we be watching?
Absolutely. That's the next frontier. Wide bandgap semiconductors,
Mm.
specifically silicon carbide, SiC, and gallium nitride, or GaN.
Terrific and Gana, okay.
These materials are game changers
Mm.
because they can handle much higher voltages, temperatures, and frequencies than traditional silicon.
And what does that mean practically?
Well, it translates to vastly more efficient, smaller, and lighter power modules.
Mm.
So for you, the listener, this means things like electric vehicles with longer ranges and faster charging times,
Ah, right.
more compact and efficient solar inverters, maybe less bulky power adapters, even more power-dense data centers.
Mhm.
While they currently represent a smaller segment of the market, their adoption is accelerating rapidly, especially in high-performance applications like EVs.
Hmm.
They're really poised to revolutionize power conversion in the coming years.
So, putting this all together, what does this really mean? We've seen that from, the industrial centers of Europe to the tech hubs in Asia Pacific, and even the rapidly emerging economies in Africa and Latin America. The demand for these energy efficient, compact, high performance power modules isn't just rising, it's surging.
It really is.
These are those silent conductors, as you called them, making our world more efficient, connecting everything from, I guess, sprawling solar farms to the smart appliances in your kitchen and maybe the electric vehicle you drive. They're critical for making our devices and systems smarter, more efficient. They're truly acting as the hidden enablers of tomorrow's technologies.
Yeah, and if we connect this to the bigger picture, this kind of consistent, widespread growth in such a foundational technology like power electronics, it suggests a fundamental re-engineering of how global energy systems operate and how we interact with technology itself.
A fundamental re
It
engineering.
really raises an important question, perhaps for you to consider. As our world becomes increasingly electrified and digital, and with innovations like these wide bandgap semiconductors really coming to the forefront, where else might these silent enablers become critical? Where might they transform industries or aspects of our daily lives that we haven't even fully imagined yet? Okay, let's unpack this. Welcome to another deep dive. Today, we're plunging right into the core of how energy gets managed, the power electronic device and module market. Our insights are coming from an excerpt by Cognitive Market Research. And, well, our mission here is to really explore this critical, often overlooked industry. It's fundamentally changing how we generate, convert, and manage power, pretty much everywhere.
Yeah, and what's truly fascinating, I think, is how these seemingly quiet components are the silent enablers behind massive global energy savings. They are really at the heart of industrial strategy, making these,
Right.
invisible efficiency gains crucial for a cleaner, smarter energy future.
So when we talk about these power electronic devices, we're really focusing on those critical interface points,
Yeah.
right? The things that enable everything from, say, an EV's rapid charging to a smart factory's optimized energy flow. Our research points to their key role across automotive, consumer electronics, heavy industrial automation. But what makes them so indispensable? Why are they needed in such different areas?
Well, the core reason is efficiency. It really boils down to that. Companies are specifically turning to advanced modules like IGBTs, that's insulated gate bipolar transistors, and MOSFETs, metal oxide semiconductor field effect transistors. Essentially, they're like ultra-fast electronic switches. But the real game changer, I'd say, is the shift towards materials like silicon carbide or SiCut. This lets these switches handle way higher voltages, higher temperatures too, while wasting far less energy as heat. Think about it. Without these kinds of advancements, a typical data center, its power conversion energy use could easily jump by over 15%. That means millions in wasted electricity, a huge carbon footprint. So yeah, they're making these invisible efficiency gains, helping us push towards, tighter carbon reduction goals.
Right, and one of the most transformative impacts has got to be in transportation, wouldn't you say? The whole electrification push. What exactly are these electronics enabling in vehicles or high-speed trains, these new mobility platforms?
Yeah, looking at the bigger picture, these high performance power modules are basically the brains controlling the flow of high voltage electricity. In electric vehicles, for example, they're not just handling the charging, they're precisely controlling the inverter that converts DC battery power into the AC needed for the motor. This also allows for things like regenerative braking, optimizing efficiency under different driving conditions, different loads, and the push towards lightweight, thermally optimized, really compact designs. That's fundamentally redefining how power gets used on the move. It's pushing the boundaries of vehicle performance, range, all of it.
Okay, so we've seen how they're redefining power on the move, EVs, trains, you name it. But that same idea, that principle of efficient power conversion, that's just as critical for our shift to renewables, isn't it? Especially when you think about how variable solar and wind power can be.
Absolutely, yeah. Our source actually calls them the unsung heroes. You find them behind solar inverters, wind turbine converters, those large-scale energy storage systems. As countries invest, heavily in clean energy infrastructure, the need for reliable high-voltage switching, seamless energy transmission, It just accelerates. These devices become critical for stabilizing grids, ensuring smooth, scalable distribution. They're basically bridging that gap between intermittent renewable generation and the consistent power delivery we all expect.
So these devices are clearly revolutionary, foundational even, but no cutting-edge tech comes without its hurdles, right? What are some of the key challenges the industry is sort of grappling with now?
You're absolutely right. One major engineering puzzle is thermal management, heat. As power modules shrink and get faster, they generate intense heat, just physics. And this heat can lead to rapid fatigue, long-term reliability problems. It's a serious concern. Imagine trying to get rid of the heat from, say, a small light bulb, but from something the size of a postage stamp, and then put that in an extreme environment, like inside a car engine or way up in a wind turbine blade. So designing effective packaging, cooling systems for these thermal loads, especially in rugged places, it's a constant battle. Materials science versus physics.
Okay, heat's a big one. And what about the cost? Getting these cutting-edge components actually into products?
Yeah, cost is another factor. Manufacturing complexity and high cost, particularly with advanced materials like Ciklani and gallium nitride, Gianna, they create pretty significant barriers. These
Hmm.
technologies need really sophisticated fabrication processes, super stringent quality control. That naturally drives up the costs, and that can limit broader market access,
Yeah.
especially for smaller companies trying to innovate in this space.
So you've got these powerful components, but then there's the challenge of making them all work together across different systems, different vendors. Is that an issue?
Exactly. Our research also points to ongoing issues with design integration and actually a surprising lack of standardization. Because power modules often need to be highly customized for different systems, engineers frequently run into compatibility headaches, which means, significantly longer development timelines, frustrating, and the absence of universal standards that really complicates deployment, especially in multi-vendor ecosystems. Think about demanding sectors like industrial automation or aerospace, where interoperability is absolutely key.
So we've laid out some tough engineering puzzles, heat, cost, compatibility, feels like a lot. But this industry isn't just sitting still, is it? What's exciting is how quickly they seem to be tackling these hurdles. What are some of the game-changing breakthroughs we're seeing right now?
Yeah, what's truly fascinating, I think, is the rapid shift towards wide bandgap semiconductors like silicon carbide, SiC and gallium nitride. John, we mentioned them briefly. Unlike traditional silicon, these next-gen materials have a larger band gap. Basically means they can handle much higher electric fields, higher temperatures without breaking down. And that translates directly into higher efficiency, much faster switching speeds, better thermal handling, all in smaller packages. These qualities are, well, they're revolutionizing everything from EVs to aviation systems, high voltage energy platforms. It's a big deal.
Okay, so the materials themselves are improving. What about how they're actually put together?
Mm,
The packaging.
right. Breakthroughs in packaging tech are making a huge difference too. We're talking about innovations like 3D layouts, double-sided cooling, even embedding power modules directly onto circuit boards. These innovations allow for incredibly more compact systems, more efficient, more resilient power systems. And that's particularly valuable in high power density applications, places where space is tight and reliability is absolutely non-negotiable.
That's a lot of physical innovation, material science. Is there a digital side to this? A smart aspect to how these things are evolving?
Oh, absolutely. Our research definitely notes a significant convergence, hardware and intelligence coming together. Power modules are increasingly integrated with digital monitoring, advanced diagnostics, even AI-enabled controls now. This allows for real-time system feedback. It enables things like predictive maintenance, optimizing performance on the fly, and ensuring seamless interaction with smart energy networks. It all connects. This evolution is particularly impactful for, say, large-scale industrial facilities and utility infrastructure,
Hmm.
places where uptime, efficiency, grid stability, they're paramount.
So what does this all boil down to for you? This deep dive really shows that from renewable energy installations to electric vehicles, smart factories, this power electronic device and module market isn't just, supporting the energy transition. It's actively powering it, often completely behind the scenes.
Yeah, zooming out, it really highlights just how crucial these specialized components are. They're shaping our sustainable future, quietly building the infrastructure for a much more efficient world.
It really makes you wonder, doesn't it? What other vital, powerful components are out there, quietly at work, revolutionizing everything around us without us even realizing it?